All right, good morning, everyone, and welcome to Building Predictable UI Components on the Lightning platform. My name is Adam Patinsky, and I'm a UX engineer for the Lightning design system. Unfortunately, my coworker Jade was not able to make it today, so I'll be going solo. But before we get started, I'm sure you've seen the slide a million times. Make sure to make any purchasing decisions based on what's currently available in the product. Luckily, today we will be talking about things that are available, so you shouldn't have to worry about that too much. So today we're going to talk about a topic that I think everyone can relate to. I know I can. And that is user interfaces are complicated. They have to work on many different screen sizes, many different browsers. They have to, many teammates are contributing to them. They're hard to test. And they can really just be really fickle and break easily. So today we're going to kind of talk about a few problem areas that might be popping up in your components. And then look at some solutions and see how we can maybe make those a little easier. So we're just going to kind of jump right in. So we kind of have like three problems we're going to talk about today. And so the first one revolves around what we call state. And you might be asking questions like, why didn't that component update? Or how do I get this component into that state? And the next problem we have is around an area called logic. So with this problem, you might be asking questions like, where's the function that does that? Or why did this component run that function? Or it'd be great if this component could do the same thing as that component. Or isn't this controller the same as that controller? And these can be all really frustrating to debug and just really hard sometimes. And third, we have some things around composability. You might be making statements like, I wish I could use part of that component in this component, or I wish I could use that component with one small modification, or why is this component doing that? And again, these can be, when you're working on a big team or you have a lot of components, these questions popping up can really just be frustrating. So my premise today is that we can make components less complicated. Anyone telling you that they have a solution that's just going to like fix all your bugs and make everything perfect is probably lying to you, but I think if we follow a few principles that we can really reduce the number of bugs in our application and make things a little bit easier to work with. So to demonstrate what we're talking about today, we've made a little application. It's a fun cat photo sharing app called Instacat. And if we look at this application in terms of like Lightning components, we have like our top level application. And then we have a feed, and you've probably seen the feeds on many different apps like Twitter. And then inside there, we have a bunch of feed items. And in each feed item, we're going to have a header, which displays like the user information and the avatar, the actual image itself, and then finally the footer. And the footer has like comments, likes, things like that. And we're actually going to zoom in on this component today. I know it looks really simple and not super complicated, but I think there's actually quite a few things in this one component that we can do to make them just a little bit easier to understand and more predictable. So we're going to kind of jump right in. So the first thing we're going to talk about is what's called stateless components. And by that, like in terms of Lightning components, what I mean like by components that are tracking state usually have private attributes. Anything that's not driven by a public attribute, it means there's like some stuff that's going on internally. And we're going to try to avoid that. So if we look at our application, each one of these blue boxes represents state. So you might be tracking things like light count or scroll position or just random things like that. And you can see as you get these blue boxes to pop up more and more and more, our application can kind of get really confusing and hard to work with. So what we're going to strive to do is make all of our state at the top of our application, and it's going to feed properties down to our components so that only one person has control of the state, and everyone else is just letting the parent control that. So do you want to? Hey, Jade actually made it, so she's going to kind of do a handoff here.
I did make it. Hello, good morning, everybody. This thing's on, right? Yep. Okay. So we're going to take a look at our code here. And here's our feed item component, and we have a few attributes here. One's for the image, and it has a map of information there. And then we have our image header. We have our image itself, and then we have the feed item footer, which is what we're going to be drilling into right now. So inside this feed item footer component, we have our ID attribute. We have our comments attribute, which is an array of strings. And we have our show comments attribute here. And you'll notice something about this. It's access is set to private. And anytime you see this private keyword in your components, it's a good indicator that the component in question is tracking something internally. It's tracking internal state. And this is like a really good place where you can start to optimize your code and remove that private state dependency. So let's keep this in mind as we go forward. So wrapping out the feed item footer component here, we have the unordered list, which iterates over our comments and displays either one or all, depending on the value of that show comments attribute. And then lastly, we have our button. And when our button's clicked, we fire off a event to toggle comments in our controller, and that sets the updates the state of the show comments attribute. So looking in our feed item controller here, here's our toggle comments function, and it just sets the private attribute from before, that show comments, and it updates it to whatever the opposite of its current state is. So this all works fine and good, but the problem comes to what happens when our component is destroyed. What happens to the show comments state? So to kind of give an example of what I'm talking about here, let's go back to our app. So, I load my app. I see this first Instacat image here, and I hit show comments, and I expand all the comments. And then I start scrolling down the feed, and I scroll past that item I previously interacted with, and the feed item is destroyed once it goes off screen to optimize performance. But then I kind of go back up to the top, and the feed item is recreated, and all of a sudden, show comments is reset. So why did that happen? It happened because when I scrolled off and the component was unloaded, and then when it came back, the component was reinstantiated like a new component. It had no concept of the thing I did before to it, and so it's reset, and that show comments attribute is reset to its initial state. So this isn't a really great experience for the user because for them, nothing changed. They didn't, have that thing go away, and all of a sudden their state's different from what they expected. So how can we improve this? Following our principle of stateless components, we can have our parent component manage the state and persist the state so that even if the feed item itself is destroyed, since the state is kept globally, that reference is persisted as the user navigates through the application. So to optimize our code to take advantage of this, we're going to go back to our feed item component, and we're going to add an attribute called show comments. And we're going to tap into our image data stores for that, and we're going to get the state of show comments for our image. And that state's going to persist and will never be lost if the user navigates away from the feed item that they interacted with. So then in our feed item footer, what we're going to do is we're going to remove that private attribute that we had before, since it's no longer private and since it's now being passed into that component from the parent component. And we're good to go. So one last thing, you might be thinking, well, what happens to our controller code and that toggle comments thing? Before it was updating the state of that private attribute. So what is it doing now? We're going to get into that in our next topic when we touch on logicless components. But real quick, to wrap up what we've done so far, we've made our application more stateless by moving that state out of the child component and into a more permanent place in our application, in the application component. So this helps keep our state predictable as our user navigates through the application.
Great. So the next thing we're going to talk about is logicless components. And I know that might sound like an oxymoron because we're writing code and building an application. But what I mean by that is we're going to try to take the logic that's in our components and as the same thing as we did before, we're going to try to move it to the top. So let's say these blue boxes now represent controller code. They're functions dispatching events, and these arrows are representing events. And as you can see, the feed item footer does something, and it notifies the parent feed item, and it does some more stuff, and it notifies the feed. And as you can see, as we get more of these boxes and arrows, it's going to be really hard to figure out who's calling what function, who's listening to what event, and it can really get out of control. So we're going to try to do the same concept that we just did with our state and move it all to the top. And we're going to move all of our main logic to the top, and the parent and the child components are now just going to be responsible for notifying the parent that they want something to happen, but they're not going to actually do the work. So let's take a look at what our toggle comments function looks like now. So now in our toggle comments function, we're going to create a new event, and it's an application-wide event. So we only have two events in our application, and this is the first one. And it has two parameters, type and payload. So the type is going to indicate as a string indicating what we actually want to happen. In this case, we want to toggle the comments. And the payload is going to be any related information that top-level component is going to need to make that happen. And in this case, we just need to know what image we're actually doing that to. So we're going to pass in the ID. And then we're going to fire it. So now we might be saying, well, who's going to listen for this event? And luckily, in our application, we're only going to have one person listening for events. And it's going to be at the very top, a component, rather. And it's called the store. And so the store is going to have this controller function called handle action. And it's going to say, OK, I'm going to grab the type and the payload that the event created. Then we're going to get the previous state. And by the previous state, I mean the entire state of our application before the user clicked the button. So all of our images, our users, our like counts, our comments, everything that we knew about before they clicked the button, we're going to get that. And then what we're going to do is we're going to get the next state. What's this state going to look like after the user clicks the button? And to do that, we're going to call a function in our helper, and we're going to pass it the previous state along with the action. And now, unfortunately, today, because we're kind of short on time, I don't have time to jump into that function. But just know that's where all the logic for toggle comments actually went. So we're going to move all that logic in there and get the next state. We're going to then save that state. And we're going to dispatch our second event. We only have 2 events. And this one's called Instacat Store. And we're going to give it one parameter called the state. And so now, any component that's listening to this event is now going to have the new current state of our application, and no one's ever going to get out of sync because there's only one state that exists in our application, and everyone knows about it now. So what did we accomplish? So we moved all of our logic to the top of our application, allowing our components to describe what should happen, not really how it should happen, which is really cool when you go back to edit your components later, and you know all your logic is now in one spot. So Jade's going to talk about our last topic here.
Yeah, so the last thing we're going to talk about today is the idea of composable components. And what I mean about composable components are components that aren't too specific and don't try to be too specialized to a certain implementation. So we want to be able to reuse our components when we need to and when we want to. So if we had another section in our app that also wanted to show comments, it would be a shame if we had to rewrite all of the code and the logic to get it to do something that's mostly the same, but maybe it's just a tiny little bit different. So going back to our code, what we're going to do is we're going to optimize this unordered list that displays the comments. And we're going to turn this block of code right here into a new component itself. And we're going to call it image comments. So we're going to replace that line of code with our image comments component declaration. And we're going to pass in the comments here. And then when we go to our image comments component, it's a pretty simple component. We're going to pass in that array of strings for all the comments. And then we're going to iterate through them. And right now, we're just going to iterate, like this is just iterating through every single comment. And you'll notice that we lost a little bit of logic from before, because before we had this kind of show comments attribute that was saying either show one or show all. So we're going to add that back in now. So what we're going to do is in our feed item footer, where we're calling the image comments component, we're going to pass in a new attribute called count. And what we're going to do here is we're going to reference that show comments attribute that we have. And we're going to, if it's true, we're going to set the value to the entire length of the comment string. And if it's false, we're going to set it to that initial 1, indicating we only want 1 comment. So when we go back into our image comments component, we're going to add that attribute in the component. And then we are going to add an iterator in our unordered list of our printout. And what this does is it gives us a current iteration index of whichever item in the array that we're going through. And then down here, we're going to add a little bit of logic that just will keep iterating and printing out comments until that number is met. So if it's the entire length of the array, it'll go till the end. And if it's 1 or any other value that we want to declare, we just pass it in, and it'll keep printing out until it reaches that number value. So this was a pretty quick optimization, and what we did here is we made our component a bit more flexible. We allowed it to show any number of comments we want to pass in, and now we can use it in the footer. We could also use it in other places as well, with maybe perhaps a little bit of different logic for what that count attribute might want to be. So that's what we've done.
So just to wrap up, we're going to kind of do a quick overview of what we did today. So we made some of our components stateless, and by that, we mean driven by public attributes. And anytime you can make a component driven by public attributes, it's always going to be easier to debug, easier to reuse, and just much more predictable. Next, we made some logicless components. So whenever you can make a component describe what should happen and not how, it's a really great way to differentiate actions from implementation. And finally, we made some components composable by making them really small, reusable, and focused so that we can repeat them over our application. So you might be saying, like, so what? Our application literally doesn't do anything different than when we started, which is like kind of weird. But I think we've gained some real benefits here. So by using this pattern across our application, it's much easier to debug. We now know all of our state and all of our logic is in one spot at the top of our application, which makes it really easy to test and really easy to just like look through when you're like, why is this doing that? You don't have to go sorting through like 1,000 components and like their controller files trying to figure out like, where's this thing that does that? They're also easier to update. Once you start using a pattern like this, when you go to make a new component or go to maybe modify a component, you already know exactly what pattern it's following. You know it's getting its properties from its parent. You know it's dispatching actions, and so there's no need to make up new event names and make up new patterns. And finally, they're easier to learn. So on our team specifically, when you have people onboarding on your team that have never looked at your code base before, if you don't follow patterns like this, they can be really overwhelming. You go in and look at you're trying to dig through controllers and figure out what functions are called and what events are being dispatched. It can be really frustrating. So following patterns like this make onboarding much simpler. So I think those are some of the benefits we've gained by doing this.
And these are just a few ideas. And the nice thing about these concepts that we've talked about today is it's not an all-or-nothing approach. You can implement 1, 2, or 3 of these as incrementally as you need to. You can do it one component at a time, and just kind of see how it helps you feel like you understand components more predictably, how it helps your team. These are great things that can help streamline processes through big, complicated applications and even simple ones. So if you would like to learn more information, we encourage you all to check out Lightning Components Basics course. This is the trailhead for that. And we have just a little bit of time for questions, I think, off stage here. So thank you all very much for coming out today, and we appreciate it.
Well, thank you very much.